Imagine designing an autonomous car that expects perfect lane markings, predictable drivers, and clear signs. Now, drop that car onto a typical Indian street. Why do Western ADAS and self-driving systems immediately fall apart here? In the West, traffic flows in neat, predictable parallel lines. But on unstructured roads, traffic is a fluid, dynamic mix. We have auto rickshaws squeezing through tight gaps, pedestrians crossing unpredictably, and a complete absence of lane discipline. To a standard AI trained on clean highways, this isn't just traffic, it's complete sensor noise. Specifically, these systems fail on three critical fronts. First, lane detection algorithms look for painted lines that often don't exist. Second, object classification models fail to recognize highly local vehicle classes like auto rickshaws or customized carts. And third, behavioral prediction models assume drivers will yield according to standard rules, whereas local driving relies on informal, real-time negotiation. Instead of waiting for a central authority to map every obstacle, we turn everyday vehicles into a collective intelligence. We call this the safe swarm. Think of it like a hive mind, where a single car acts as a scout for everyone behind it. Let's see how this works. As a single vehicle moves down the road, its built-in camera detects a hazard, like a deep pothole. Using real-time computer vision, it immediately flags this spot with high-precision GPS coordinates. Within milliseconds, this metadata is broadcast to the cloud. The platform instantly pushes an alert to all nearby vehicles. Before the next driver even rounds the bend, their dashboard warns them to slow down, turning a potential crash into a minor, well-managed detour. To prevent accidents in real time, we cannot wait for data to travel to a cloud server and back. Every millisecond counts. That is why Civilytix processes everything directly on the device using a tight, three-step edge pipeline: capture, detect, and warn. First, we capture. The device's camera continuously grabs high-frequency video frames of the road ahead. Second, we detect. A highly optimized, lightweight AI model runs locally on the processor, instantly projecting bounding boxes around hazards like deep potholes or unmarked speed breakers. Finally, we warn. Once a hazard enters the critical collision zone, the system triggers an immediate audio-visual alert for the rider, giving them crucial split seconds to react. This entire loop happens in under 50 milliseconds, completely offline. To reach zero road fatalities by 2050, we must shift from reactive measures to a proactive, shared intelligence network. Real-time telemetry doesn't just help a single driver in the moment. It aggregates into a permanent ecosystem where every mile driven makes the entire network safer for everyone. At the center is the Civilytix hub, synthesizing swarm data. This intelligence feeds three critical pillars. First, commercial fleets optimize their routes around active hazards. Second, insurers assess risk dynamically based on actual road conditions. And third, city planners pinpoint structural black spots to redesign infrastructure before accidents occur. This continuous feedback loop aligns commercial, financial, and civic forces. By transforming chaotic telemetry into collaborative action, we build a self-healing road network, paving a clear, data-driven path to zero.